Good evening, everyone, and welcome to today's Reactor live stream session. Just wanted to let everyone know that you're more than welcome to ask questions throughout the session using the Q&A box. Our presenter will be taking questions throughout the presentation today. If you want to get some more information on the Microsoft Reactor, feel free to check us out at meetup.com/Microsoft Reactor Sydney, and I will talk to you later on this evening about some upcoming events and ways you can contact us. So without further ado, I'm going to hand you over to Ananth, who will be taking you through tonight's presentation.
Thank you, Nadia. Good evening, everyone. My name is Ananth Prakash. That's me on the video. I work as a cloud solution architect specializing in data, AI, and IoT in Microsoft. One of the key remits of my role is to ensure the customers, the enterprise customers who adopt Azure, do so without any problems, and we push the solutions that they want to deploy into Azure with minimal fuss. With that, let us get started. I'll turn off the video to save bandwidth, and I will get started talking about machine learning ops. Again, just to come back to Nadia's points, feel free to drop in your questions anytime during the presentations. I have put in certain breaks during my presentation, during which I'll try and answer some questions. I also have a demo to show you. So after the demo, we will probably go through and I'll go through and answer all of the questions that keep coming up. So what are we going to talk about machine learning ops, right? So I'm sure you've heard machine learning and DevOps, and these are the two hot buzzwords at the moment. Machine learning, as you all know, is becoming more and more accessible to many organizations, but with that increased accessibility, there also comes the need to manage the ML projects in the same way that we do our software development projects. MLOps, or machine learning ops, or machine learning operations for DevOps, as we call it, is the confluence of DevOps and machine learning, and that is what we are going to examine today in the presentation. So let me sort of start off with an analogy of a programming construct, right? So let's say you're doing software development or application development. So when you're doing a programming, we solve a problem by writing algorithm. We run the data or input, whatever you pass, through that algorithm, and we get an answer. Importantly, we can work out how to solve the problem, or rather we know how to solve the problem because we write the code for it. But what happens when we don't know what that algorithm looks like, right? So these are the problems that machine learning is really good at. With machine learning, we solve these problems by flipping it around and providing a whole range of examples, data points of correct answers and corresponding inputs of what you want to find out. And we let the computer decide what the good algorithm is going to be. Now, these are some of the basics of machine learning. I'm sure most of you might know, but let's sort of go through it and see how it changes. What we're essentially doing in machine learning this way is letting the computer describe, or computer build a model to describe the data that you're passing it to. Right now, by using the models, we can get predictions. Now note these predictions are not answers, right? The way we think of an answer. No, it's not an output that you get. It's not an answer that you get when you run a software algorithm, what we saw in the first step. The quality and accuracy of these predictions depends on the techniques and the algorithms we use to train the model. And most importantly, the data that we use to train the model. If you're using biased data to train the model, you will get a biased model, right? Now, so far, it's all good. We've got the basics of machine learning, but how does a machine learning process actually look, right? Usually, there is always some data discovery, there is a transformation, there is a preparation, and some kind of a building of a model training using the data, right? Now, this process is highly iterative and an experimental process. That means you might go back to the drawing board many times over a very long period of time. When the time actually comes to deploy a model into production, as we call it, it is often similar to the way we do it in software, right? So you package the models and let the developers or the operation team deploy it somehow. Now, how it happens in the real world, though, ideally that's the way it should happen. But what happens in the real world? The creation process, or the model creation process, happens on a data scientist's machine. It could be a desktop or a laptop or whatever it is, or it could even be a shared hardware that has been provisioned for training the model. And deployment most often happens by passing a USB drive around, or sometimes you even send a model pickle file or another data file through emails. Now, it might seem to you that this is not the case, but I've seen many customers who actually still today follow the same process to deploy models. Now, I actually found this tweet somewhere wherein the lady who's out there said a very good quote saying, it took me 3 weeks to develop the model, but it's been greater than 11 months and it's still not deployed. And it is so very true in the real world. So before we jump on to understand what is the process or what is really machine learning DevOps called, let us try and understand what the traditional DevOps process looks like, right? Let's contrast this. So a traditional DevOps process is a place where you plan a release, you develop and test your code artifacts. Most of the times your development and testing would have a source control repository attached to it, wherein you push your code or your software into it. You run some test cases, your test plans, your different style of testing, unit testing, functional testing, integration testing, smoke testing, etc. And then you sort of release them to the production environments. You would have your own release cadence and your release cycle processes to do that. Then once the software or an application has been pushed to production, you monitor and learn what happens in production. Now, but the key question is DevOps just only for software development, especially the algorithms that we spoke at the start, right? Let's see what it is. So let's try and define what DevOps is. Now, Microsoft definition of DevOps is this. DevOps is the union of people, process, and products to enable continuous delivery of value to the end users. The most important word here is value. DevOps is not about code or bug fixes. It is about continuously delivering value, and that's why we call it CI/CD, right? So if you have a predictive model, you can always make that model better. That is absolutely valuable. So this definition doesn't exclude machine learning in it, right? So let us now look at how we could probably define machine learning ops in this case. So machine learning, as we all know, is a place where you build experiments, you retrieve data, you have your own business understanding of the landscape, which is called a domain knowledge, and you then build your initial models and you develop the scenarios as you go along. It is quite an iterative process, but you also add the development and operation process to it. So the development part of MLOps comes into play, wherein you do testing. You have CI/CD integration to make that development process pretty repetitive, wherein you create a model, you plan, you verify, and you package your model assets. And then you move on the operation cycle, wherein you release that particular model. You sort of, let's say, deploy that model into an environment where that model could be used within applications, within business applications, to probably make use of the model recommendations to build a subset of more applications that are valuable to the business or the customers, right? And while it operates, you always have a data feedback loop, and you always continue to monitor the model and the systems that it is deployed on. Now, let's try and define MLOps in the same way that we've defined DevOps a while ago. MLOps, or DevOps for machine learning as we call it, enables data science and IT teams to collaborate and increase the pace of model development and deployment via monitoring, validation, and governance of machine learning models. As you've already seen or observed, we would have always two different personas when we talk of machine learning ops, right? So in a classical case, you have a data scientist, and you would have an SRE, or let's say a DevOps engineer or a software engineer or an applications engineer, as two different personas. So the job of a data scientist would be to build and train models and deploy them into production, whereas the job of an SRE or a DevOps engineer or an application engineer would be to use the predictions out of those models into their application or into their services, and further push their DevOps processes along. I'll show you an example as we move along in this presentation as to how that cohesion or how that interaction between the two different personas actually work. Now, in terms of MLOps combines the expertise of both camps, like I spoke, the data scientist and the let's call them software engineers or DevOps engineers, or of both camps for more efficient machine learning that leverages both sets of skills, right? MLOps puts your operations team at the forefront of new regulations and best practices. So your operations team can take ownership of the processes while your data team can concentrate on deploying creative data models. The operationalization helps to close the loop between gaining insight when you build a machine learning model and translating that particular insight into an actionable business value when you deploy that model into or integrate that into different applications. MLOps or DevOps for machine learning, like we've seen, in my opinion, is increasingly becoming a necessary skill to set and focus for enterprises looking to leverage the benefits of machine learning in the real world. With that, let's look at actually what are the actual benefits that an MLOps can give you, right? So these are some of the three key pillars of what I think the benefits would be. One would be automation or observability. You build, one of the key things being you can build recursive or reproducible pipelines, which are reproducible or unverifiable. That sort of adheres to your model reproducibility, pillar of what we say. You can always generate and deploy code drives in an automated fashion, and you can always tag and audit all the artifacts that go as part of this particular cycle. You also get validation, wherein in terms of the software engineering best practices for quality control. So you learn how to do source control and release control management. You can always do an offline comparison of model quality. Don't confuse this with A/B testing. That is a little different, but you could always compare to see if you have to retrain a model, how you could do an offline comparison with model quality. And you can always minimize bias and provide descriptiveness for a model in the validation phase. And in terms of reproducibility or auditability benefit, you can always control your rollouts of the specific capabilities of a model. So you may have a need wherein when I said about A/B testing, you could probably have two versions of the same model deployed as two different endpoints in a champion challenger methodology, and you could actually control to roll out those capabilities. You could have probably 4 different versions of the same model, but in a champion challenger methodology, but have one version, 2 versions in one specific geo region and 2 different versions in a separate geo specific region, but you can still control it, right? And you can always it goes to say that the results feedback by detecting your not only by monitoring the drifts of the model, but you can also look at the data drifts. You can interpret what your model is doing, and you can always use these feedbacks to go ahead and retrain and improve your model. So if I have to put in a nutshell, this is what the DevOps loop for data science looks like, right? So if you look at it, MLOps follows a very, very similar pattern to DevOps. The practices that drive a seamless integration between your development cycle and your overall operation process can also, transform the way your organization handles machine learning or big data life cycles. So, in addition, getting your models into production efficiently, MLOps ensures the responsible use of AI by enabling auditability, which we spoke. So let's look at an example, right? So let's say a customer is denied a loan that they have gotten that they should have actually got purely because the model predicted the risk capability of that person incorrectly, right? So we in the real world, in an operations world, we need to look at the exact deployment, the version of the model that was at fault, track down the dataset code, the environment which was used to train the model, and see why the actual mistake was made. Again, using the model interpretability, you need to even look inside your model to see why it behaved the way it did during both training and inferencing. Now, at this point, what I would also say is, Azure Machine Learning, which is one of the frameworks that I'm going to show you in the demo and talk about in the upcoming slides. That is the framework or the technology that gives you all of these features to make sure that you can audit trail a model. So Azure Machine Learning has an audit trail management feature that does this for you, and it also gives you SDKs to interpret a model and monitor the data drifts while the model is being inferenced in production. We will get to those bits at a later point of time in this demo. So I'll probably just take a quick pause here and see if you have any questions before I move on and just discuss about how an MLOps workflow looks like between the two different personas I spoke. One as an app developer who's using DevOps, or in this case Azure DevOps, and one data scientist who's using Azure Machine Learning. I'll probably quickly take a couple of questions if there are anything. Nadia, if you have any questions.
Ananth, at this point, it's there's no questions that have come through, so you're more than welcome to carry on.
Perfect. Thank you so much for that, Nadia. So let us quickly look at how an MLOps workflow looks like, right? Like I said, the 4 key pillars and what you see in MLOps, generally what Microsoft Azure recommends is, your model should be reproducible. Your model should be, you should be able to validate your models. You should be able to deploy your models, and you should have a function capability to retrain your model. All of this needs to happen in a seamless fashion, hopefully in an automated fashion as well. So in this case, let's say there are going to be 2 different personas. An app developer who's using Azure DevOps to probably use the same DevOps cycle of checking the source code into source control. In this case, it's a Git repo. He builds an app. Running a build, he releases that, he tests that app, does a release, and then continues to monitor the app in production. Let's see how MLOps can work with the data scientist coming in place. So as a first step in terms of model reproducibility, the data scientist would use Azure Machine Learning to code to probably code the models, using all the data sets that he needs to train that model, using pipelines, and even the environment versioning, right? So you would have specific environmental dependencies that would be needed to sort of build this model. So all of these dependencies would be checked into a source control management. This way, every single time, if you need to run multiple different iterations, all the data scientist needs to do is to probably change the code or change the environment versions and use a different data set. And this model could be reproduced at any point of time pretty easily. And so as a next step, you could always train the model. The data scientists would train the model. So the training could happen in 3 different ways. You could use either automated machine learning, or you could also use machine learning pipelines, which are sort of you can chain multiple different pipelines or multiple different tasks or steps in the machine learning process to actually build that pipeline. So one could be training a model, splitting your data set, training a model, making sure the hyperparameters are tuned correctly. You can also go ahead and evaluate the model if it's performing correctly, etc., etc. Once you have built a model, the next step would be to actually go and test it. So you would probably do some unit testing or some functional testing to make sure that the model is correct. It works the way it has to. Let's say some of the things you would see is how accurate the model is. If you're using some accuracy metrics to measure your model, if it's a regression model, probably you would see what is the root mean squared error, does it fall in the right values. If it's a classification, you would probably look at the area under the curve metrics, etc., etc. So you actually go ahead and validate your model, how it works, and then you actually go ahead and see how it works probably on the test data set, right, which we would have created as part of the data splits when you've done that. In terms of model deployment, let's say you've got a model that works in the best way possible. You probably go ahead and then package that model using very simple deployment steps and make sure that this deployment can be done anywhere. In Azure Machine Learning, we recommend to actually deploy a model as a container, because a container becomes like a small unit of work, and that way you could deploy the models anywhere you want. Not only on, let's say, a web server as a REST endpoint, but you can also deploy that container model on edge. You could also run your model on devices, for example, right? So, or on IoT devices. So you could even have your phone, and you could run your machine learning model on the phone if you have the right Azure IoT runtime running on the device. So there are many industrial customers, and especially in the customers on the retailers whom I work with, wherein we've actually deployed models at the edge as well. Now, after the model deployment is done, what obviously you would want to monitor the model, make sure that the model's accuracy doesn't drift, or if it drifts, is it due to data, is it due to the model performance, etc., etc. And you would love to probably retrain your model. So you would also look at your model performance analysis, and then go ahead and build a retraining piece of it. All of this you would love to be automated and to be set or configured in a way that it works seamlessly. So let's say once the model is already deployed, you would then have your app developer actually go ahead and use that machine learning model as a REST endpoint into the applications that he's building. So if you actually look at this workflow, for a data scientist, it is no different than what this workflow looks for an app developer. It's just that there are some additional steps, and those key bits, the reproducibility, the validation, the deployment, and the retraining is what makes MLOps such a compelling proposition for businesses to use, right? So, and once all is done, you would probably have a happy data scientist. Like, yeah, there you go. That would be the reaction of someone who would probably use it. Now, let us look at how probably the handshake between these two personas happens in the real world, right? I'll take questions after this slide before we move on to the demo. So let's say in the real world, you have two different environments. Let's call it one as an on-prem environment, one to be a cloud environment, which is used for model serving in Azure. You have you have the data lying in on-prem, and you have two different personas, a data scientist and a site reliability engineer, or let's call them as machine learning engineers. Right now, let's just say they have got a bunch of requirements. So the data scientist says, hey, I need to quick iteration and train next to my data. Right, so I've got new data sets coming in. I need to retrain my model. The ML engineer would say, well, our requirements, we need to handle the production loads, and we need to ensure this model has been geo distributed. So you can see totally two different requirements, totally two different use cases, but they still follow the same process. And let's see how the handshake works. So they decide, yep, let's do this, and off you go. So first, the data scientist would say, let me go and check in my code onto GitHub. That code check-in automatically kicks off a CI/CD pipeline. That pipeline would trigger, let's say in this particular example, trigger a Kubeflow pipeline on-prem, right? That Kubeflow, it processes the data, it does a training run on the process data, and when it's done, it automatically registers the model. What we are going to see in the demo is going to be how it is done in the cloud, right? Now, once it's done in the cloud, what she does is, the ML engineer would take that particular model artifact or a container and provision it as a staging endpoint. And from there on, she would probably, trigger out the CI/CD pipeline one last time. So she uses that endpoint in her application, and let's say triggers the CI/CD pipeline one last time. And you roll out your application out to the world. So like you can see, you have two different personas doing two different things, but the DevOps process completely looks the same. And this is how the real world application of MLOps really happens with like I said earlier, it is not about building a model which really works, but it is about how do you actually take the insights that a machine learning model that you have actually built, how do you take that insight and convert that insight into an actually actionable business value? And this is a classic example of it, where a model endpoint has actually been used in, let's say, one of the business apps and rolled out to the external world. So a classic example of this is one of my customers, where they actually serve a machine learning model which does price recommendations based on specific customer groups and their loyalty membership details. So it is done when the customer goes online and makes some purchases dynamically. They get some discounts applied based on their privileges, loyalty privileges. Same life cycle, same workflow is used over there as well. Now, before I probably move into the next section of how does Azure Machine Learning and Azure DevOps makes it possible, I want to see if there are any questions quickly. I'll probably take one question here before one or two before I move on into this section. So if there are any questions for me, Nadia, let me know. If not,
sure. We've got two questions that have come through. The first one is from Ritesh, and his question is MLOps a new technology or a concept?
Good question, Ritesh. MLOps is not a new technology at all. No, like I said, it is a methodology. I wouldn't term it as a technology, right? So there is a difference between methodology and a technology. It is a process, like I've just explained in my slides. Now, is it a new concept? Ideally, if you think about it, yes. And if you look at why it had to be a new concept, I think I've just already spoken about it, right? Because the key reason being the data science group, or let's say the analytics group in any organization, or the data scientists, they've done a phenomenal work in building out these machine learning models which had to be used. But it took such a long time to actually define a process to get these models into production and actually use those models in a real life business applications to actually get a business value out of it. The transition time was so long and so mired in different process delays across multiple different organizations that that we had to sort of come up with this new methodology saying, okay, the life cycle of the way how you build a model and deploy to production is no different to the normal standard DevOps processes. So we just had to sort of find a way to intermix both of them and come out with MLOps. Hopefully that answers your question. What is the next question, Nadia?
The next question is it likely that data scientist and an app developer are the same person?
Well, from what I've seen at my customers, no. Ideally, you would have them as two different personas. But if you have been an app developer in your previous life and are doing the role of a data scientist now, then yes, absolutely yes. It really doesn't have to be two independent people, but generally in big enterprises, you would definitely have them as completely two different personas, because app developers do a completely different thing to data scientists, right? So if I go and tell a data scientist to probably go build a Java application that probably deploys a WAR file into a web server, it's very difficult for them to do. And same thing with an app developer. If I go tell them, take a random forest algorithm, make sure you only use 400 leaves, and make sure the model is homogeneous and has the best features, they wouldn't know it. So it's quite likely that both of them are going to be completely two different personas, unless it's a small organization and there's a need for a data scientist to also have an app developer expertise. Right. So with those questions, I'll probably move ahead. Thanks so much, Nadia. And after this, I'll come back at the end of the demo and take those questions if you don't mind. So like I said, for MLOps in Azure, we have Azure Machine Learning Framework that allows you to build all the things that I've just spoken about in terms of model reproducibility, validations, deployments, retraining, including interpretability and data detections, etc. So what is machine learning on Azure? So what are the capabilities that we offer, right? So we have domain-specific pre-trained models, to reduce the time to market for applications. So this is what we call as our cognitive services, or Azure cognitive services for people who are aware of it. So we've got about models that are in vision, on speech, on languages, and on search. So we have a cognitive search as well, and we also give you familiar data science tools to simplify your development tasks. So if you love PyCharm, if you love Jupyter, VS Code, command lines, well, it's all yours. Pick any of those choices, and we've got a lot more as well, but I've just listed sort of 4 here, and gives you your choice of popular frameworks, be it PyTorch, TensorFlow, Scikit-learn, anything else. One key thing is where we've partnered with Facebook to actually build what we call as Onyx, which is an interoperable machine learning deployable format. So whenever you are deploying your model, generally we recommend people to deploy it on Onyx format, which means this format is recognized anywhere. So you could deploy this model anywhere, and your model could be inferred as well. And what it also does, it sort of reduces the size of your model deployment. So it is, I think, about 1.5 times lesser, or probably 2x times lesser than the actual average size of a model container. So Onyx is probably a great format to choose. And we also have more productive services to actually empower the data science and the data engineering groups as well, wherein you can bring your choice of your own computes to probably build your models. You can bring Azure Databricks if you love Spark. Azure Machine Learning itself comes in with its own sort of computes and IDs, or if you just want a remote training to be done on the cloud, you could always use machine learning VMs. And we also have GPU-enabled machine learning VMs coming in there. And finally, at the hardware layer, you also need a powerful infrastructure to probably accelerate your models. So either on the CPU, so we give you 3 choices: CPUs, GPUs, and FPGAs. So FPGAs is what we use when you want to do real-time inferencing at edge, and that is something we use mostly at all industrial solutions. We also have ASICs that are coming up, but probably at this moment they're only used in the US in a big way. So what exactly is Azure Machine Learning Service? So that's machine learning on Azure, a lot of portfolios. But what really is Azure Machine Learning? Microsoft Azure Machine Learning provides enterprise-grade capabilities to accelerate your machine learning lifecycle. It is nothing but a set of Azure Cloud Services with your choice of language framework. So you can either use a Python or an RSDK that enables you to not only developers and data scientists of all skill levels to build, train, deploy, and manage models responsibly at scale. So before we jump onto the demo, let me quickly show you as to what Azure Machine Learning sort of looks like. We are going to see all of this in the portal right away. So we have a concept of what we call as data sets, wherein you can actually register your data to be trained across a machine learning model. We have a concept which we call experiments. Experiments holds your training runs, your pipelines or your general training workflows, your models generally stored your registered or version models. You can always version control your models as well. Your endpoints is how we give you two types of endpoints. There's a real point endpoint, which is how you deploy a model, or you also have pipeline endpoints. And I'll show both of these things here. So your training workflows also can be exposed as endpoints when you do it. So we offer multiple different types of compute. So we give managed computes, or you can even bring your own compute if need be. You can define multiple different environments. So your training and inference environments can be defined. And finally, your data stores are your actual connections to data. So I'll give you a difference in what data stores and data sets look like. Data stores are your actual connections to your true data source. So if you're having your data, let's say in an Azure blob store or on a database, your data store is a logical abstraction of that particular database or the blob store. Your data set, in other terms, is a subset of the data that is stored in those data stores. So let's say if your physical database has about 100 tables, your data store is could be a logical abstraction of 50 of those tables in that particular database. Whereas your data set would be, you could have 50 different data set, each data set mapping to one table, right? So that should probably be giving you a good idea as to what they are. Now, with this, I will probably jump off to the MLOps demo, and just let me know, Nadia, if you can actually see the screen, or are you still seeing my presentation deck?
No, we can see your screen. You're all good.
Perfect. That is awesome. So before we jump on to Azure Machine Learning, Azure DevOps, I'll probably want to show you what Azure Machine Learning Studio looks like. Now I've got about 5 different tabs just to make sure that I don't waste time switching over from one part to other and losing my data sets here and there. So Azure Machine Learning, like I said here. So if you generally go to ml.azure.com and sign in with your Azure AD credentials, you see this particular portal. Now, what we have here is, like I said, if you remember all the bits and pieces, we have what we call as experiments, or we also give you the capabilities to bring in your own notebooks and an own file. So in this case, I've integrated my notebook with my different files. So these are some of the contributors, some of the peers whose notebooks I can reference in my particular workspace. You can see I do not have any notebooks here, whereas my peers have their own notebook samples put in here. So you can actually have your own notebook samples and probably open them and start working here. It gives you the automated machine learning capabilities. In this case, I've run some automated ML pipelines here. We also give you what we call as a designer. So for people who are citizen data scientists, who are not experienced data scientists, who don't like to write code, if you want a UI feature wherein you can drag and drop and build your models that way, this is what the designer allows you to do that. I'm not going to get into these details now, but it's just for your idea. And like you can see, we also already provide a lot of other samples that you can use to build it. Now, the key part of this demo would be, data sets. So if you remember, I was talking to you about some data sets. You can actually see, what a data set generally looks like. So in this case, let's say there's a connected car component. So you can see this is the data set details. So you know what is the data store, where it is created from, how many files are there in this data set, etc., and what is the current version of it. So like you can see here, you can even version control your data sets in this case. Now, if you want to consume it, in this data set, we also give you a sample code, which you can just pick it up and copy it to your notebooks or to your favorite IDE and just run with it. It's just as simple as that, right? So everything is like pre-built, pre-baked for you. And there are a lot of other things that are in there. I'm just going to, for the sake of interest, I'm not talking about machine learning here. So maybe that can be my next talk. And I'm doing it. Let us quickly jump onto the explore option. You can, if you're a data scientist, you can actually go and explore and see your data sets as to how much it is and what they look at. In this case, it's connected cars, so this is how we look at it. And like I see, you can always switch across different versions of your dataset. So this is how the version 3 looks like. This is how your version 2 looks like. And this is how the latest version of the dataset currently looks like. And you would actually see as to why it is so very important, because you can have your specific machine learning models. Now this is a model version 5 which uses this particular specific data set. So if I go to version 2, you have a different model but with a different version which is using the second version of data set. So if you really want to always retrain your models and know which data set it was trained on, this is one way of dealing with it. There are multiple other ways you can see it, but you can directly see it through your data set itself, because you could have the same data set used across multiple different models in multiple different versions. Right now, quickly coming off the experiments, this is where all your model training runs are generally shown. I'll show you the experiments that we are going to run in our demo, so let's not probably waste too much time on it. The pipelines are your machine learning pipelines. You will see more of this when I run the demo and the steps that you have. So just to sort of give a quick example, there is a run in the pipeline. So like you can see, we give you a list, we show you in a graph mode as to what the different steps in the pipeline were, or you could also see what the steps were and what the runs were, what are the outputs and the logs from that specific run of the pipeline, right? You could see your standard error logs, you could see your execution logs, if any, your metrics that you see for this model. For this particular case, we have not defined any metrics, so you don't see it. The images, if any, you have created for this snapshot, you haven't, etc., right? So, and what is the raw JSON of that particular run look like fundamentally, right? And if there are any explanations for the model, which is the model explainability part, which is again a preview feature, like you can see, you could also see that in the same place. And this is again for one single run of an experiment. So consider this to be one training run in your model, and you can actually see for that one run, if you have enabled all of this, you can actually see what the explanation of the model would look like. So, and that way you could have multiple different runs. Now, as I said, for a model, if you let's say you've built your training, you've done your evaluations, and you want to register your model. So what you do is actually we can go ahead and register your model, and you can register a model with multiple different versions. So in this case, you can see the compliance classifier model has 5 different versions in it, right? And you can choose and deploy whichever versions that you want to deploy into production. And you can also see you can always tag a model. So your tag could be, what is the type, what is your run ID, what is the build number for the model, etc., etc. All of this comes pre-baked when you use DevOps. Now, so this is where you actually. So if I have to, let's say, open up a model. So this is where you would see what the model name was and what is the description of the model. What were the different artifacts that went in? So like I said, we've used the Onyx format for the model. So it's an Onyx format model that we've had. What are the different endpoints? If you remember, there were 2 different types of endpoints. One was a real-time endpoint, one was a training endpoint. This is one of the real-time endpoints that you get when you deploy a model. And you can also see that in the compute sets. You can look at the explanations again. Like I said, it's an extension I've not enabled here. And you can also finally see what are the data sets that this model was used to build this. Now, when we go to endpoints, you remember I showed you 2 endpoints, the real-time and the pipeline endpoints. So this is how your pipeline endpoints look like. So every single time you run your pipeline, it is exposed as a pipeline endpoint here. And these are the real-time endpoints. So these are the endpoints when you actually go deploy a model into, let's say, a Kubernetes cluster or onto a web server, and you get a RESTful endpoint or an HTTP endpoint, for you to consume that particular model, right? So if I get into some of these real-time endpoints, you would see it's loading, and that's what happens when. Okay, so probably I'll let it load very quickly. I'll probably go to my section where I've deployed the models here. So you could actually look at when I open a model with MLOps AKS, you would see that it comes in with the details of what the model endpoint is, how it was deployed, etc., etc. So you can see here now this becomes your REST endpoint for the model. So you can always use this REST endpoint to run scoring or probably run inferencing, whatever term you want to use against a specific model. Now, this is all Azure Machine Learning, by the way. Like I said, we have multiple different compute instances that you could have to run your model. This could be your notebooks here, or like I said, you could use the pre-built compute clusters that Azure Machine Learning by default provides you. So in my case, I've trained the model on a specific cluster here, whereas on a different instance, my compute clusters could could have been multiple sites, right? Like there are 4 different compute clusters that have been put. There is now what we also give you is a capability for you to bring in your own attached compute. So you would remember Azure Databricks to be one of the services that you can attach to training models. You can also use Azure HD Insights, which is nothing but a Hadoop cluster, wherein you want to probably bring into train a model in there. Now we also have an inference cluster section wherein you can have a Kubernetes service as an attached cluster, wherein you actually deploy your models to have as an endpoint. Right, and finally, this is where I spoke of the concept of data stores, where you have these data stores which you create as a logical wrapper over a blob store. So in this case, my account, I've put it against an Azure storage account, and my authentication type is SAS token, and the data sets are created out of this particular data store of my site. And there's also a new feature that is coming up in machine learning, which we call as data labeling. So what the data labeling actually allows you to do is to have a set. Let's say you've got a set of users who you want to use to say, do a data labeling construct. So let's say you've got a lot of. I just created a data labeling for an object detection scenario here, right? Just for the sake of this demo. Now, if I look at the data, I have uploaded 3 different pictures here, and I want to have an object detection scenario wherein I want to have bounding boxes on specific items. Now I cannot do it myself, but I would want a human to actually come in and pick up these data sets and label them. And as the humans label them and save the labeled data sets, I would also want to have I would want to trigger off a machine learning process that understands how and why a human has probably created a bounding box, to take that as a learning. So the next time when a new data set comes in, you don't need a human to actually go in and probably label the data. The Azure Machine Learning framework itself would, based on what it's learned, would try and go ahead and label a data set. So this is again, just a quick example I wanted to share. You can label multiple different types of projects. So in this case, I can labeling task could be image classification or multi-class image classification. It could be multi-label or object detection in this case, right? So that is what I've created here. Now that's all about Azure Machine Learning and how it looks. Now this is what a data scientist would use, but where is MLOps in this, you may ask me? Well, here is where we bring it all of them together. So this is Azure DevOps, and the first thing that we do in Azure DevOps, whenever you want to say spin up a machine learning project, is to probably I'll probably have to show you what Azure DevOps is. I'll get there. So Azure DevOps is nothing. Let's say we have a concept of organizations wherein you can actually create multiple different organizations. That's a logical construct. So an organization could be, let's say, a project team or probably a business group within your company, and you would have multiple different projects that you can define under that particular organization. So in my case, MLOps demo is under my project, under my organization on Jack, whereas as you can see, I have multiple different other organizations and 6 more where I am a member of those projects. So in this case, I have this MLOps demo, which is my project under my organization. So the 2 key things what I have to do here. Number 1, you have to go in and add an Azure Machine Learning extension onto Azure DevOps. I will put all of these links. I'll share all of these links in a slide deck so that you can do it. So this machine learning extension allows you to go ahead and use Azure Machine Learning Services natively within Azure DevOps. So what I mean by that is, when you go ahead and deploy a model to, let's say, a Kubernetes cluster, or let's say, a Kubernetes cluster running in my Azure Machine Learning workspace, we get native integrations directly by using this extension on Azure DevOps. So, that is and you could have GitHub triggers that directly call these native extensions there. I'll show you how that all works, right? So that is the first step. Go install this extension on DevOps. Second, you would have to go ahead to project settings, and we have to configure what we call as some service connections. So what does service connection have? So to run any machine learning ops sort of on a life cycle, you would need to provide your Azure Machine Learning workspace connection to your DevOps. So Azure Machine Learning workspace is nothing but this particular section. So when you log on to ml.azure.com, you log on to what you call as your workspace. So workspace, consider a workspace to be a logical isolation point for all the data scientists. So you can have one workspace per project, or you can have one workspace for a, let's say, a business group. A workspace in Azure Machine Learning is very similar to, let's say, what an organization was in DevOps, right? So and for people who are not familiar in Azure, we have a concept of resource groups that allows you to group individual resources together. So in this case, I have a machine learning operators group, and I have a workspace, machine learning workspace created under that particular resource group. And I provide the details of that particular workspace as a service connection so that Azure DevOps would know or would have a credential to go and connect to that workspace and deploy or make use of whatever compute instances I've configured here, or it can actually go ahead and create these compute infrastructures directly on this workspace. In my case, you see all of this provisioned. It's not I haven't provisioned these. The Azure DevOps pipelines have automatically provisioned all these clusters to me. Right. The key thing that you need is an Azure resource connection, and Azure resource connection is to give DevOps access to log into your Azure Machine Learning portal or give access to your Azure Resource Manager that allows you to probably have a service principal which is sort of taken it on your behalf or as a proxy and goes and creates resources for you in Azure Machine Learning. So these are the two key things that needs to be done as a step 1 and 2 before we start to go ahead and then create your DevOps pipelines. Now, in the pipelines, so this is how your general MLOps demo project looks like. You can see I've already had about 6 different runs. That is basically my 6 different talks that I've had in the past probably 6 months on this particular same topic. So actually, let's go ahead and look at what are the repos that we use, right? So this is my repo, which is actually being checked into GitHub directly. And if I actually look at it, let me do this first, right? Because this particular demo takes some time to run. So what I would do, I would probably just go and let me actually change the name of the model file and retrigger a pipeline as we speak, so that by the time your questions finish, I can at least show you what the process looks like. So this is the normal way, probably, let's say a data scientist would do. You could go ahead, change your code or change your YAML configuration files. And what we generally do is you go to pipelines, you create a new pipeline. You just follow the prompt saying where's your source code, it's Azure Git. You can see I've got 2 different Git environments, but I'm just going to use my MLOps demo project. I'm going to use an existing YAML file. I'm going to take it from the branch master because I don't want to use any other branches, not tampering the work of other users. And I'm going to just use the diabetes regression CI YAML file and just click on continue. Now you can review your pipeline and then schedule run, and your pipelines will just start running. We will come back to it and see what the pipeline looks like. So there will be 4 stages in the pipeline, like we've already seen the stages. Number 1 would be the model CI, wherein your source control, your code would be pulled from GitHub. The code would be built as a package, and then your model. So you can see the first step has already started. Then you would jump into a stage where your model would be trained. Once the model training and evaluation step is done, we would go to deploy to ACI. This becomes your testing phase, and finally we move it into production. Considering this is demo, I've not put in any stage gate approvals, but you can always have approvals put in place, and I'll show you when we get there. Now, let's allow that machine learning pipeline to run, and let's come back to our repos, and let's look at 2 key files here, right? So I'm using the diabetes regression data set. So I'm just using a simple scikit-learn regression algo to sort of find out what the trends of a diabetic person sort of looks like. Now, there are 3 different script paths to it. So these are where my training script is. This is a Python demonstration, so I'm going to use Python. But if you're interested in R, we also have our training code here. Again, whatever you see here, all the code here is open sourced. I have included the links in this deck, so you would get everything back after the session. So we also have scoring scripts along with the deployment scripts that DevOps could use. And like I said, if you're performing an A/B testing, you can also do an A/B scoring as well. And finally, you have a Python script that registers your model. So if you want to look at what those scripts look like, it is, like I said, a simple Python code that is there. So if you remember from the data set, you could pull in a code, you could do the same things here, right? So you define your machine learning workspace based on your workspace name, your subscription ID, and the resource group that we have seen. You build an experiment that you've seen. We've seen what the experiment looks like, and then you can just go ahead, run the experiment, get the model names, and finally do a bunch of different stuffs, right? And finally, you can actually go, if you have your model, you can go and register your model. So if your model doesn't exist, it goes and registers your model. If the model is already registered in this case with the same run ID, the same version, the model won't be registered, because fundamentally your training run, your code when you have checked in, and the new CI pipeline that has run, and the new artifact that was built, the new model artifact that was built, we did not find that the new model was any way better than the model that was already existing. If the model that you have built is any way better than the previous model, then the new model will be registered. That is what the model registry Python script effectively does. And again, you have the same evaluation code in Python as well. Right, so these are your standard codes that a data scientist generally runs. Now, if I quickly come off to the pipeline, let me show you as to what the critical YAML file looks like. So this is the YAML file. If you remember, I submitted as my pipeline, right? So what are the different stages in this pipeline? The same stages that you've seen in there is defined here as well. So you have a model CI as a stage wherein you pull in your working directory, you invoke the Python to build and publish a training pipeline, right? And this has multiple different stages, like you can see, and I'll show you all of these stages once the pipeline finishes, or I'll pick up one of my existing pipelines and show you. So it is just a bunch of stages and tasks and jobs that are defined inside those particular stages, right? And finally, that is all it is to it. Now, so we've seen the source repo, we've seen how to create the pipelines. Now you might tell me, Ananth, you showed me these settings. You've shown me the code. You've shown me how this pipeline runs, but how does Azure Machine Learning really know that the name of the workspace is this, and you have to use, let's say, this AKS cluster, etc., right? So how can you actually have all of those details sort of stored in? So all of those details are generally given as part of your parameter files. Or sorry, not the parameter file, sorry, my bad. We give all of those details in what we call as variable groups fundamentally, right? So if I have to quickly pull out those variable groups here in the pipelines, so okay, let me probably pull out an existing pipeline and the existing run for you, and then probably showcase as to where those variable groups go. So this is one of the so if I go to the pipelines here, right, so this is where I've had all my previous pipelines. So let us quickly go and see how a general MLOps demo pipeline looks like in this case. So this was triggered in the same way as we've triggered here. So you can actually see the summary of the runs. When did it start? How long did it take? What are the works that were published, etc., etc. You could always set up code coverage here as well. I haven't said. So you can actually go ahead and see how many test cases were run. So this is where you come to your DevOps part, wherein you actually develop and test. So this is the development and testing part of your machine learning model, right? On stage 2, when you train and evaluate a model, this is what you do, or probably in the stage 3 when you test what a model looks like. So you can always go ahead and see what those test cases and other bits and pieces sort of look like. In this case, I've fully taken probably the failed run, so sort of hooray, and I got a cup that there are no failures. Now you can always run code coverages. In this case, and I've just run a simple code coverage here to see, how many statements are missing, how much of the code is covered by those test cases. For people who are not familiar with code coverage, for those data scientists, let's say if your code has 100 lines of Python code in it, your Python file has 100 lines of code in it, and you create a test case. Ideally, a code coverage says how many of those 100 lines in your Python file did your test cases cover? How much percentage of it was covered? That is, in a very, very high level, is what code coverage is all about. That is effectively a parameter or a metric to measure how effective your test cases are. The better the code coverage, it means you have a better test case, or your tests have better coverage across the whole lines of code that you have written. The lesser the code coverage, in this case, like 45 or 52, which clearly means, on my training testing, I'm not doing my testing of my training Python script very, very well. that is just like a quick crash course on what code coverage is for all the data scientists out who are listening here. So like I said, this machine learning pipeline went through multiple different stages, and you have actually seen all of these stages as tasks in the YAML file. But what we generally do is, we could run, because this is a code that you check out of GitHub, so you can run lint tests, you can run your unit test, you publish the as part of the stage, you publish the test results, we publish the code coverage results, and we even publish the Azure machine learning pipeline here. So what Azure DevOps does in the background, whenever Azure DevOps has to run these pipelines and stages, it spins up its own container in the background. So at the end of every stage, you would actually see stop containers. So we have these DevOps agents that are running, and each of these tasks and each of these steps is created like a self-contained unit of work. So we have these containers which are deployed. We run these all steps that you see in that particular container. Once that step is run, we stop those containers and delete those containers out. So that is what DevOps actually does in the background. So in this case, we deploy a container, run lint, run unit and test cases, blah, blah, blah. So that is what your first model CI is. And in my case, in your case, your model CI could also be your provisioning of your infrastructure as code. So in this example, my model CI was to go ahead and create these experiments, these data sets, these endpoints, and this particular machine learning workspace using Azure DevOps. That is what my initial model CI was. Now, if we come to the training model piece of it, so you see the first step would be get a pipeline ID for execution. In Azure machine learning, every pipeline has an ID. So for your DevOps agent to know what is the pipeline ID it needs to run, you need to give it an ID. Now, you have to understand Azure DevOps is a tool, right? And this machine learning service is tied to my identity, which means I will log in using my Azure Active Directory credentials into this portal. Only I have an access to this resource. So for Azure DevOps to have an access to my environment, I need to provide what we call as a service principal to it, right? So in this case, if you look at it, especially in this particular step, you could see a step where, and again, all of this runs using Azure CLI commands, right? So you could see the Azure DevOps actually logins using a service principal. So the user and a password based on my tenancy. Everything is grayed out for you. I've provided all of these in the variable groups of what I've defined. So that is how a service principal that is impersonating me is used to connect to my machine learning workspace. And how does it know which machine learning workspace to connect to? It is all defined in the settings section. So this is where you have to actually build those settings as an example to see, so this is where you manage your service principals, etc., etc., etc. I cannot show you what my managed service principal is, but this is the way it is. So when you set up a workspace connection, you actually set up all those service principal details as well as that part. So that is what the service principal is. So the service principal impersonates me and has the same privileges as me. That allows Azure DevOps to actually go and provision anything on my workspace. And it's the same thing that you would do or your operations team or your engineering teams would do when you go and deploy your machine learning models in there. So again, so let's say the pipeline ID is got, you've logged in, and then you actually come up the point to say you invoke your actual machine learning pipeline, right? So in this case, the command to invoke the machine learning pipeline is done via a RESTful endpoint. Again, this demo is to showcase what are the different methods in which you can invoke a machine learning trigger point. So the previous step you saw to get the pipeline ID, we used Azure command line interface. In this case, you see we are using a RESTful endpoint. Now there is another mode also as to how you can use Azure machine learning frameworks. We also have an SDK option. That SDK option is nothing but you see using the Python code, right? So you can see you could have a wide gamut of ways in which you can actually use the Azure machine learning framework or even the Azure framework to actually go ahead and build your MLOps model. So in this case, I'm using the RESTful service that Azure machine learning service gives me, and I just post a request to invoke my machine learning pipeline. So in this case, you can see the resource group is MLOps RG. Like you've seen, the provider is Microsoft Machine Learning Service. The workspace is my workspace that you've seen in the page here. So this is my MLOps AMLWS workspace. That is exactly what you see here. And I say, OK, invoke the pipeline runs and you pipeline submit. And this pipeline submit, the ID here is what you see in the first step. So when you did a get pipeline ID, that is the pipeline ID that we submit to say run this particular pipeline on that particular Azure machine learning, and we do it using the the RESTful endpoint. Now, once that model is run, let's say the pipeline runs successfully, all the training is done, you would actually want to see if the evaluation has succeeded, because that has, like you've seen, 3 training steps to it. You train a model, you evaluate a model, and then you make sure that the model is successfully evaluated. So if it's already done, you want to see if the evaluation is done and the model is registered. So you do the same thing here using Azure CLI. I'm not going to go to the nitty-gritty details of it. It is the same login using the service principles, and then you can see, there's a simple bash script, that we run here as part of which is part of the source code that I've showed you, which actually goes ahead and does all those determinations for us. So let's say once this particular stage is already done, so this is the train model stage. So you've created a models here, you've trained your models. It's a repeatable pipeline, so your model is reproducible, as we saw in our decks. The next step would be, let us deploy this model to a remote local instance, right? This is not production, by the way. Let us call this, let's say it could be a non-prod or a QA environment, or even a remote testing environment, a remote development environment. In this case, I'm using Azure Container Instances, which is a lightweight way of standing up a quick model. So again, the critical and the most important step here, I'm going to skip all the other steps that it does. It is open source. You go through it at any point of time. So the critical step here is deploying that model on ACI. Now, if you remember, I told you need to add an Azure Machine Learning extension. Because I've already given that extension to DevOps. DevOps knows that and goes ahead and adds an extension itself. So as you can see, everything is self-done for you. You need not do anything. All you do is one click, and I'll also show you how you even need not do that click manually. So the key thing here is, it logs in, gets a service principal, and then this is the key command here, right? So Azure Machine ML model deploy. It gives a name. It picks up the name that we've given in the variables file that I've shown you. It picks up the model libraries regression file. So if you remember, I had changed the model file. Now, again, this is the name that I had given previously. We had changed the pickle file to number 12, right? And you would see when our pipeline runs, you would see that it uses the same file, right? And it says where the scoring inference file is. So if you remember, I showed you all of these files, in the GitHub repo, all the inference config files and your scoring files. It says, what are your dependencies, and just goes ahead and creates a deployment package for you. So essentially what we take here is your conda dependencies, your environmental details, your scoring script, your data set, your actual model file, etc., to actually build up a machine learning model package. So once a machine learning model deployment is successful, here you actually get out a scoring URI. After this, you can actually trigger your smoke tests to make sure your model works well. This is the evaluation or the actual testing of how your model works. So if you remember the workflow between a data scientist and a machine learning engineer, this could be for a data scientist and a machine learning engineer to run a quick smoke test to say, using that particular scoring endpoint, does my application work the same way as expected, right? If using my current recommendations, that is what you would actually look at. Now, let's say your model runs well on production. On non-prod environment, and you want to actually go ahead and deploy a model to production. So in this case, this is where I move and deploy my model in production to an Azure Kubernetes service cluster. Again, I'm going to jump or skip all the details. Again, the simple command here is, like I said, the Azure Machine Learning deploy. In this case, you can see the container that it has to use is AKS. And if you know what is this AKS, if you remember, this is the compute name that I've specified. Now, I haven't created this compute like I've told you earlier. All of this gets provisioned automatically in the very first step when you run a model CI. So clearly DevOps clearly knows what is the exact compute and where and what kind of pickle file it has to pick up and go deploy that model. And after the model is deployed, normally, you would again have a similar scoring URI that you got, on which you can run your smoke tests and make sure that everything works. Now, this is what happens when we run a normal machine learning pipelines over here. Now, as a very quick check, let's see what is happening on which stage. So it's still running the training stage. In our side, a model is still being trained. So you can see there are two steps that is already done, and it's determining if the evaluation of the model has actually succeeded. We will actually come back and see it. Now, it might so happen you say, hey, Ananth, you actually ran a pipeline manually. Is there a way they can automatically trigger it? So you would have seen I saved my repo and it asked me to create a pull request. So is it possible for us when a code is check-in is done and create a pull request and build a release and build the pipeline in automated fashion? Yes, absolutely. So if I have to go and do a quick pipeline, let's say, I'm just going to close this stage here for a minute. So let's say I add an artifact to create a release. I would say artifact is going to be my MLOps demo. The source is going to be, let's say I pick up any one of those, my 6th run, right? And now I'm just going to sort of, add this artifact. So this is going to be my GitHub repo, for an example, and I can choose a trigger. So my trigger would be create a release every time a new build is available. So if I'm checking in a code and creating a pull request, which means a build is available, and every single time you check in a code and create a pull request, this is going to get triggered, right? This particular release cycle is going to get triggered. And what are the stages that it's going to do? So you can go ahead and add a stage. So let's say in my case, I say, I want to go ahead and deploy my model, for an example, right? So I would say, OK, just go ahead and deploy machine learning model. In my case, I'll just go ahead and apply, and then sort of leave it there. Now you could clearly see this has about 2 different tasks. Now, if you remember in the very first stage, I said you need to have install an Azure CLI ML extension. So I'll have to provide my subscription details here. Now I can just go ahead and manage my subscription details. I don't know why it's not picking it up here, but generally let's call it, let's say it picks up and Azure subscription details here, or you could always, if you don't want it, what I could always do, I could actually take this off and show you a different way of probably deploying a model as well. So if you take this off, we can always, let's say, add a new task, and I'll say AML, for an example. And you could, sorry about that. Right, so I could always have just an Azure ML deploy task as an example, right? So I can add that, and I would probably go back to the settings and say, OK, what is my machine learning workspace in this case, right? So I'll give the workspace connection details that is needed here. I could supply and model artifact. So in this case, I could actually go ahead and link my artifact directly here, whatever it is. Or if you want to manually specify it, you can always say, what is the model name that you want to use? So in this case, if you remember, we had created this model 12. So you can see the machine learning pipeline has already gone ahead and created a model. So this is where the model 12 pickle file is. You can choose a model version. You can see there are 2 versions of it. I'll probably choose the latest version of it. And what does the inference path looks like? Let's say, let's give the same path to it, and give certain deployment information. So let's say this is going to be a QA deployment as an example. And the deployment configuration file, you could just go ahead and pick it up directly, from the YAML file. So for the sake of our demo, I'll probably just pick up one of the deployment files. That is often just given here. So once this is set, I can always save it to a folder. Probably, I'll just probably leave it to a comment, or I can go back to my pipelines, and you can see you have a task. I could always add another task, or I can clone this stage. So if I go to this stage, I can change this stage name to say, QA deployment, and come back. It automatically saves it, and I can always go back to this stage and say, this is production deployment. And every single time I create these stages, I can always add tasks to say, I need to ensure that there is somebody who's providing approvals when I'm going to sort of go and deploy these models. So you can always add those bits and pieces every single time that you go, right? Now, if you remember, I told you at the very start that we have what we call as a concept of variables that you have to define for your machine learning models, and this is where it picks up all the variable groups that I've already defined for this particular DevOps projects, and just brings those in and uses these in this new pipeline. So this is a very simple way to sort of create your own new releases, which are automatically triggered. So in this case, I have manually clicked a release pipeline, but you could always go ahead and create your automated MLOps pipelines to actually deploy your models across different environments. Now, with this, I sort of come to the end of my demo. I'll probably not save anything here. So if I quickly just go back to the model stage, I'll probably just want to quickly show you as to how the new model has sort of gone ahead and created a new pickle file. So I think I've already shown you that in the demo, right? You've already seen that it picks up the latest pickle file, which is number 12 in there. So what did we get off here in this case, right? So let's look at what now the next steps. This is what I've shown you was just an example, right? So what did we learn? We could see that the models may be embedded in software or applications through a RESTful endpoints. You also read that in terms of the machine learning services that we offer, Azure Cognitive Services are a great starting point for you. So if you do not want to build your own machine learning models, you can always go ahead and use the pre-baked cognitive services, and they have great APIs that Azure pipelines can actually talk to. And Azure pipelines, which are your DevOps pipelines, can orchestrate literally anything. So whatever set of tools you're using, you can actually manage it, use it to manage your machine learning training. Let's quickly have a summary. So those are the different components that Azure Machine Learning brings you. So what do we see? All code and infrastructure are in source control, which means your infrastructure and code can be provisioned as a code as well using DevOps pipelines. You have the capability to attach your known and shared data sources. We've seen what is the key difference between an Azure Machine Learning pipeline and an Azure DevOps pipelines. Right, your DevOps pipelines is more a CI/CD orchestration, whereas an Azure Machine Learning pipeline is how you build your training and testing and evaluation pipelines in Azure Machine Learning. It is important to have retraining strategies as part of your organization to get the true value out of MLOps. And finally, DevOps always utilize the good DevOps good practices for delivery of any project. So here are some documentations. So if you want to learn more about Azure Machine Learning in detail, that's the link: AKMS WAC MITT WAC ML docs. Just go read up on it. There's some great set of features, great SDKs. Use it. I'll share the link of the GitHub as well. Just go and explore and have fun with it. Also, to complete interactive learning exercises, I've put in three links in there. So if you want to learn more about AML, MITT WAC Learn AML, and if you want to learn about DevOps specifically, it is MITT WAC Learn DevOps. And for all the details about this particular project, it's aka.ms/MLOps. So that's the GitHub repo. The third one is the GitHub repo, where you would find all the source code for what I've shown you in this demo. With that, I come to the end of my session. First up, Nadia, thank you so much for having me as a speaker in this session. I know we've gone a little over time, but I hope everyone here had a very good, crisp understanding of what MLOps is and how it clearly intersects with DevOps, how you can have different personas use the same set of tools and processes to actually, bring ML machine learning into real business applications. So when you build a model, you get an insight, but converting that insight into actionable business value is what MLOps allows you to do. Hopefully you've got to see all of those today. Thank you so much.
No worries. Thank you for that, Ananth. We do have a couple of questions that have come through if you've got some time to answer them.
Yes, absolutely. Why not?
Sure. Okay, so one of the questions were, are there any tools training being covered with some sample on each stage?
Could you repeat that question, Nadia? Are there any tools or...
Are there any tools training being covered with some samples on each stage?
What specific tools training are they referring to? Can they give me a bit more detail?
Yeah, if you did ask that question, would you be so kind enough to please elaborate if you were still on the line, and we can come back to that. I'll move on to the next question, which is, how is DevOps different from Agile methodology?
Well, that's a funny question to ask in a machine learning ops, but I'll definitely answer that. Well, DevOps and Agile, like I say, both of them are methodologies. Agile methodology is just a different way of working. I would put it that way. So you would have definitely seen a waterfall methodology wherein the way the tasks are done is, again, as the name suggests, is in a step-by-step approach. So if you have to, let's say, build a software or build a machine learning model, what is it that the first thing we do? We go ahead and say, okay, what is the requirements, right? So you understand the requirements. It could be technical, it could be business. Then you go ahead and say, okay, let's find out an impact analysis. Let's do an impact analysis and see if this solution is already in production, how will it impact our other downstream systems. Let's build a solution architecture. Let's build a solution design. Once the architecture and designs are built, you go ahead and code it. Once you code it, then you go ahead and probably deploy that model into production. So there are several stages that comes to a software development. And it's the same thing with machine learning, like we said. In a waterfall practice, you do it one at a time. So you don't start your execution before your design finishes. You don't start your design before your requirement or impact analysis finishes, right? So that's what waterfall for you. Agile throws all of these concepts out of the window. Agile says, bring in a high performing team. So you bring in specific stakeholders out of each of these stages together into one team or one virtual team, and make sure all of these tasks are done in a repeated fashion, or rather in a repetitive fashion. So you can call it using Scrum methodologies fundamentally to build the same process of software. It's just that this is more iterative. It is more quicker. You don't have to sort of wait for a code to be deployed in production and tested and to know, oh my God, this code failed. So if it's a waterfall model, if your production deployment fails, you really have to start back from step one to actually find out why did this fail. But in an agile, you don't have to do that. DevOps, as the name suggests, is, let's say, a tool or an application of your agile development practices. So agile probably uses your DevOps as a tool to actually realize all of those practices that are defined as methodology. So if it is going to be source control, you would use GitHub as a DevOps. If you have to create a release, you would use your release pipelines like you've seen in DevOps, right? So hopefully that gives you a good distinction. Agile is a methodology. DevOps is probably, again, a methodology, but gives you the tools and the practices that enables you to realize, your agile development practices.
Awesome. I think we'll just do a couple more. So we've got one that says, what is the cost for deploying and training the model?
I really want to qualify again. I want you to be a bit more specific on what is the cost. Now, I'll probably answer the question, but you can come back and ask follow-up questions on that. So if your cost is about what is the monetary cost for me to deploy the solution? Was that the question, Nadia?
Yes, that was the question.
OK, so if you're going to ask me what is going to be my monetary cost to deploy my solution, well, all you have to do, in my case, I've used Azure Kubernetes Service. So if you go to the Azure pricing page and look at what a Kubernetes service would cost you based on the way that you use it, that is going to be the cost for you to deploy a model, right? So it's a cloud environment. You pay as you go. You only pay for the service when you use it, right? So if you are using an Azure Kubernetes service, and let's say you're using a specific compute against it, let's say you're using a VM, a memory optimized compute VM as part of the Kubernetes service, and let's say your cost would be, as an example, would be, let's say 20 cents an hour. I'm just taking an example. Now, don't crucify me if you think that is higher in the pricing page. So if you're going to be deploying a model, let's say for 8 hours in an 8-hour window, so your cost of deploying that model in that container would be 8. And if you're using the same VM, it would be 8 into 20 cents, would be $1.60 for the 8 hours. That is a monetary cost of it. Now, if you're asking the cost in terms of how do you build your business justifications or a business cost to justify why you need to use cloud or why you need to use DevOps and Azure Kubernetes Service, that is a whole different conversation altogether, because that cost is not the cost of the service that you use, but that cost would be the cost of the whole solution architecture. It would be cost of the people, resources, the security teams, the security parts that you put in. It's an overall cost that would come in. But if your indication to cost was not monetary and not business, probably go ahead and qualify that further, and I'll probably answer that question afterwards again.
Sure. Another question we have from Benny is, what does the version number for data sets mean?
Good question. So version number for data sets. I'll probably try and go back and share the screen and explain that over there, right? So like I said, if I go to a data set, let's say, and I open up a data set and a version number, what I mean is this, right? So like I said, a data set, let's say a data set refers to one table in your database. Your database has 100 tables. Your data store has a logical abstraction of 50 tables. Your data set is one table from your database, or probably one file out of the multi-million files that you have in your file system. So that one table can have, let's say, 100 columns, right? Or 100 features, let's put it that way, for your machine learning model. Your version 1 would have only 80 of those features, which your model would probably want out of it. Your version 2 would only have 60 of columns. Your version 3 would only have 40. Version 4 might have all 100. So your data set actually maps to the data set that you use to train your model. And that's why you version it, right? Because you could actually use the original data set or have a subset of your data to train your models and version those data sets as you go along. Hopefully that answers your question.
Awesome, and we'll make this one the last question and then I can go through some upcoming Reactor events. So this one is, it seems that a lot of works in the process belong to app developers. What is the main role of a data science in this process?
Great question. Well, the key work for a data scientist is actually to go and build a model, right? So if you look at what I've shown you here, the key work for a data scientist, if you look at the DevOps here, the repos here, the key work for a data scientist is to actually go and build. Do you see my screen? Nadia, I'm sharing my screen.
No, so let's reshare that. I took over the screen there for you.
Okay.
Sorry about that.
No, that's fine. So if you looked at the scoring and the training scripts and the register and the evaluation Python scripts and the YAML scripts that I showed you when I started the demo, that is all the work of a data scientist, right? So it's only a data scientist who knows or understands how to train or score or build and register and evaluate a model. The data sets, it's only a data scientist would know how to use Azure Machine Learning Framework. The experiments that I've shown you about the compute clusters, the data sets that I've shown you, model registering processes, all of those a data scientist would actually have to know, right? But then again, he or she wouldn't have to do it manually or no, but they could actually use Azure DevOps to actually do it. Now, the job of an application engineer here is to not sit down and help the data scientist build this MLOps process. No, it is the job of the MLOps team, or like I said, an SRE engineer or probably a change management engineer who will probably sit with the data scientist and help them sort of go through this process until such a time a data scientist becomes empowered and configures releases to run automatically. An application engineer job here would be, once a model has been pushed to production, is to actually take that model as a survey RESTful endpoint and use it within your application. So if you remember the ML workflow that I showed you with 2 different personas, the ML engineer's job becomes, after a model has been deployed into production, is to take that model endpoint, use that model endpoint into your application, and then check your application code into GitHub, and then allow your application your application DevOps processes to run. So your application DevOps processes would be building your own release, building an application release, testing your application, and then pushing your application into production. So your application could be a website, and that website has a price recommendation. The price recommendation is the machine learning model, which has been created by the data scientist using all this code, which has been pushed into Kubernetes service. So that is the whole difference in the persona. So if that's the last question, Nadia, I'll probably hand it over to you, unless the other 2 people came back with follow-up questions.
They haven't come back yet, but I will keep an eye out. So while we wait for that, I was going to take you through a couple of the upcoming events that we do have at the Reactor in the next couple of weeks. I just also want to let you know, if you do want to join our community, you can follow us on Meetup at meetup.com/Microsoft Reactor Sydney. We're also on Twitter. We do record all our sessions and upload them to our Microsoft Reactor YouTube channel as well, so you should be able to find the session up there within the next day. And if you do have any questions and you want to email us, you're keen to get involved, you want to do a live stream with us as well, just email us at reactorsid@microsoft.com, or you can also find me if you want to reach out personally. You can find me on LinkedIn. It's just Nadia Heta. So a couple of events that we have upcoming next week is a virtual quizzes and community engagement with Power Platform session. So we've got 2 MVPs delivering the session for us, and they're going to do a deep dive to just about Power Platform and how they actually invented a pub quiz. So with COVID happening and people not being able to go out socially, they ran this all online. So they're going to deep dive through some Excel and Power Automate and stuff like that as well. We also have a session around build AI bots for the next wave of computing with Bot Framework Composer. So this one is creating bots and learning how to deploy them to like Facebook Messenger or Microsoft Teams and some other platforms as well. We then have another session if you're interested around Microsoft Teams and Power Platform. And again, it's very similar. And this one's about, how you can build bots and do customizations with Power Platform. So if you do have any feedback, I have popped this link in the chat as well. You're more than welcome to let us know in the Reactor survey. And if you could please just enter the event code, which is 7700 at the start of your survey. So we want to thank you guys for joining us today, and thank you to Ananth as well. We do have a newsletter of upcoming events, and we are updating our Microsoft Reactor meetup page constantly. So without further ado, I just want to thank you all for joining us this evening. Thank you, Ananth. I'll put the content out for you guys tomorrow. And yeah, if you've got any feedback, let us know. So thank you, Ananth. It was really great.
No problems at all, Nadia. Thank you so much.
Awesome. And thank you. We will catch you next time. See ya.
Absolutely. See you. Thank you. Bye-bye.